Today is Sunday, October 19th. It is our middle of the month meeting, middle of Sunday afternoon, so that folks like Johnny Red can join us without it being the middle of the night for him. Um, and we're going to talk about, some updates. Carl Miles has been super busy and apparently does not stop, even though he's, got three, four projects in the fire. He's like, oh, gotta
Yeah.
fire up another one. And then we'll talk a little bit about the TS Pico, which is with the help of Ryan and Ricardo and Tim and a bunch of other people. The update is nearing completion. It's been a long slog, and we just keep discovering little issues. So that's what sort of holds back. And also, the same set of people, but in particular, Jeff Burrell and Joe Van de Zandy have started working on a modern version, recreation, improvement of the Timex Sinclair 2060 bus expansion unit that never happened. We have a little tiny bit of documentation, available to us, thanks to Lon Hildreth's preservation efforts when he left Timex back in '84. Um, and so we know some things about its, external dimensions and some of the specs about what kind of features it should have had, and that has been the jumping off point. But the thing that Jeff largely has been doing the hardware, the thing that Jeff has designed is way more powerful than what Timex ever imagined. So with that, Carl, I'm gonna spotlight you, and uh, it's all yours. Run with it. Tell us about the things that you have been up to all summer.
Okay. Well, let's see. I'm going to go ahead and share my pictures here. So let's see if this works. Mute that.
Yeah. Oh, that reminds me. I have a question for you when we get to it, but go ahead.
Okay, so this is kind of like David was mentioning. My brain keeps coming up with new things, and I don't know, it's an OCD or what is the other thing? Uh AC8
ADHD?
AH8. Yeah, yeah, that I can't stop um making these things. But anyway, this is kind of, I had talked about this quite a while ago. This is kind of like, I'm calling it kind of a super expansion. Um, but this is basically the bottom board. There's two boards that are going to be sandwiched together here for this. So, because it's got so much crap in it.
Hmm.
um, so of course on the left side there, I don't know if you can see my mouse. I don't know if my mouse comes
Oh,
through
very
on the
tiny.
screen.
Yes.
Oh,
Very
it
tiny screen.
does? Okay. Well, anyway, so this obviously is the connector that goes to the 1000 or the 1500 of the ZX81, right?
Yep.
So that's where it would plug into that. This P1 connector here, this is the whole bus, but it goes up to the top board, right? So the top board will have access to everything on the bus. Obviously, kind of here in the middle-ish is, and thanks again, David, for getting me these sound chips. That's going to be helpful here once we get this to try it out here.
Hmm.
Um, this is obviously the AY sound chip on a 1000. This underneath that or below that is the IO decoding logic,
Hmm.
right? To get it on the ports and all that stuff. There's some stuff underneath the chip that you can't see. Mainly it's the clock, not necessarily the clock generator, but because it's taking the clock from the bus, but it has to divide it down, I think, in half. And so there's a logic chip under there. I don't think I have a bottom picture of this, but suffice to say, there's some stuff underneath the sound chip. This J1 connector is kind of another thing that holds the top board on, but it also, excuse me, it also transfers some of the, you notice an audio jack is here
Oh,
for the sound output. So it kind of, it transfers some stuff to the top board because there's the amp and all that stuff is on the top board. because there's a speaker. You don't really need to amp for the line out here, but you can plug it in and it'll shut off the speaker and so forth, right? And it's stereo sound.
Oh, so that's a
Although,
switching jack.
right, right.
Okay.
So the AY sound chip here has three channels, right? So the C channel kind of is mixed, so it'll be kind of a mono channel, but the A and B are left and right, right? So it's kind of how they do it. Um, And then, of course, underneath that here, these three, the memory chip's not there, not in there yet, but the two joystick gals are in there, and of course the DB9 joystick port down at the bottom. So it has joystick capability and, of course, sound capability. At least that's what this board does. And then, of course, on the end here, it has
Remind
a,
me, the joystick is what? Is it just an Atari compatible or
yep,
comes in or
Atari
yeah?
compatible, two button compatible. Yeah. So,
Oh,
And
two button. That's not Atari compatible then.
well, it is, but you know, it's single button Atari compatible, but it also has an input for the second button,
Like
I
oh, for a
guess.
7800 or something?
Maybe, yeah, I don't know what they did,
Okay.
but
Oh,
they ran
okay.
another I/O port so it can take two buttons, right?
All right.
And then of course on the edge there's it's a pass-through connector, right? So you can plug something, further down on the bus for this. All right. Let me go to the next. Yeah, there we go. Okay, so this one here is the top board.
oh my
So a
gosh.
lot of stuff going on this board. Maybe I should put some stuff on the bottom board from this one. But anyway, this is kind of a first rev here. So on the far right here, well, far left, actually, you can see there's the P1 connector, right? That's obviously that
Yeah.
big bus connector. So that'll kind of hold the board on top of the bottom board, along with the J1 that's over here. That those two will match up. All these are jumpers here. These jumpers are just like on, we'll talk about it when I kind of get to the 1068 thing, the KiloZ thing, but it's the same design, right? Just copied over here. So you've got a 512K chip here. So you've got a ton of memory, right? I kind of wanted to put on here, at least to give you a 16K RAM pack, right? So when you plug this thing in, you're going to have 16K, right? So you don't have to put a RAM pack on. It's already here. And then, of course, with these jumpers, you can select what chunk. There's 8K chunks, right, in the 64K memory space, so you can enable or disable any of them in there. So, you can put stuff into other parts of memory, including the ROM area, 0 to 8K. So that's what we call the shadow ROM, and so you can set the jumper to write to it. You can set the jumper to read from it if you want it to boot from a different ROM that you have in this chip, or you can
Mm.
disable it like it is now, which will just boot off of the chip that's inside the unit, right? So you can put different ROM images in this and have it boot from it and actually write to it. You'd have to write a program, to write to the lower 8K because obviously the ROM can't write to the ROM, but if you have this set to write, it'll actually, you're writing to those addresses and it'll trigger this chip, and so it'll write into this chip right from the 1000. So that's kind of nice. Um, then kind of down here, this is M1 not circuitry
Hmm.
right here. This logic, that's what the switch is for, to enable or disable the M1 not circuit. Again, that's for, if you're not aware, that's maybe mainly so you can run machine code above 32K,
Mm.
which normally you can't because of the way the video display, takes A15 and other lines and stuff, and one, and, so at least when that's on, you can, run machine code above 32K. If you leave it off like it normally would be, you can actually run basic programs that are bigger than 16K, which there are a few.
Oh, that's what I was just going to ask.
Well,
Is there programs that support that already?
Yes, there's some
yeah.
There are.
programs that are bigger than 16K.
Okay.
Yes.
Yeah, there are a few, and there's an accounting package for
Oh dear.
can you believe this crap?
Well, I think there's a Star Trek game too that's bigger than 16K that people were talking about too.
Oh, there might be, yeah.
Hmm.
But so you need to have that switchable. So if you're going to run, like Hot Z or something like that up in high mem, you need to turn them one not on. And if you want to
Hmm.
run basic, you have to turn. So that has to be selectable. So that's what the switch down here is for. Then of course the big chip here is the memory chip, and then there is stuff underneath it, which you'll kind of see here. Um, this is underneath the board. You can see there's a logic chip under here and a bunch of passives. Um,
Hmm.
and those kind of control the memory decoding, right? Since you got all these jumpers here, that controls the memory decoding. That comes pretty much from Oliger, John Oliger.
Hmm.
That's
Hmm.
his circuit. Um, Moving on, well, down below is the speaker. There's so you'll hear the sounds if you don't have an audio uh, thing plugged into the jack. It'll come
I
out
don't
the
see a
speaker
speaker
here.
there. Show me
Yeah,
the speaker.
Well,
that's
it's
one
a
of those
square.
modern surface
Yeah,
mount
it's a
Oh,
rectangular speaker
really
things.
right. It's a really thin
like
speaker.
piezo speakers or something they're called? Is that what that
It's
is?
not a piezo. It's actually got a membrane there, but and I haven't heard them yet, so I don't know what it sounds
Okay.
like. But hopefully they sound okay. I kind of looked at the frequency response. It should be decent, but we'll see. And kind
They're
of on the
similar
bottom too.
to
Go
the
ahead.
ones used in cell phones. These
Yeah. It should be comparable to that. So I mean, it should sound okay.
yeah.
I
Well, it's
mean,
better than what the 1000 has.
yeah,
Yes.
exactly. Again, I'm looking at the underneath because that's where the battery goes. So the memory is battery backed if you wanted to, right? If you put a battery in there, it'll back up the whole thing. Except for every time you boot, of course the stock ROM code is going to clear out the original 16K. So that it saves it, but of course the ROM erases it. So unless you custom made a ROM that didn't erase it, it's going to. That's the only reason why it gets erased, is because the ROM does it, right? So it is battery backed. So you can stuff in the upper memory or even in the different banks, which is not really um, developed here yet. That'll be later, but I just said, well, I got all these parts from the other project that I'll just use them in here too, right? Might as well. But anyway, eventually you would have 8 banks of 64K, right? So you could have 8 different whole machines running in this thing. This kind of middle here next to the cartridge port, this is the cartridge selection logic that's taken just from the cartridge IO board, right? Basically copied over
Hmm.
here. And then of course, this is the middle cartridge port is the TS1510 cartridge. So that's the game cartridge basically, right? And the memory circuit in here is aware of this cartridge. So if you plug the cartridge in and you have, let's say, because the cartridge needs 16K to 24K and it needs 32K to 48K, right? That's kind of where the cartridge memory lives. So
Hmm.
it will disable that automatically. So if you have it enabled over here and you plug a cartridge in, it's going to disable it.
Oh
Otherwise,
wow.
they would step on each other, right? That wouldn't work. So that I took that into consideration. So yeah, you plug a cartridge in. We'll see if it works. I don't know yet. We're getting there. But that's the intent anyway. You can't have both memory spaces open at the same time, right? So the cartridge will tell the logic under here to, hey, disable those and only use what's on the cartridge. So that should work just like, the 1510 cartridges work. Um, that's about all I have to say about that. And then of course, J1 up here, this 8-pin thing goes to the bottom board, carries most of the audio signals from the sound chip. You've got a little volume pot over here. Um, I don't know how useful that is, but at least it's there. If it's too loud, or you want it louder. um, if you want it louder, you might as well just plug it into the audio jack underneath and send it out to the TV or to an amplifier or something, right?
Hmm.
This chip here is the LM386. That's the amplifier chip, and its associated, cap circuitry here. There's some diode selection logic for the cartridge port, a big 1,000 microfarads for the output of the amp. And then of course got to have the obligatory reset switch. Didn't leave that out. Now this cartridge port here, this is the ROM cartridge port. So you can actually have both in there at the same time because they're back to back. They're kind of flipped around so they won't interfere with each other if you plug them both in. So this obviously will allow you to, run different ROMs from the ROM cartridge. Now,
Oh,
granted, I had mentioned that you can put a ROM image in here, but that's just one, right? With this cartridge, you can have up to eight 8K images and up to four 16K images,
hmm.
right? So some people were like, well, why would you have 16K? Because, well, you have this like SPONSI, right? Which is the spectrum on the ZX81.
Yeah.
It uses 16K. So, although now thinking about it, I have to look and see because if you have these enabled, I don't think I have anything to disable that over here. So that may be interesting. So I have to make a mental note about that. But anyway, that's what that cartridge is for because I have the two things already, right? I have the ROM cartridge device and then I have the 1510 clone, right? So this kind of combines them into one unit, right? So you can use them both.
Hmm.
And then of course over here is just some audio circuitry, mixing circuitry for the channels, and then some more caps for the amp. And this is some logic for the ROM cartridge. And that kind of covers that. I know that's kind of a lot to put into this board, but I
Carl, I
think
have a quick question. I see you have a whole bunch of writing on there, like toward the right-hand side. Does it
yeah,
explain what the jumpers do, or is that
that's kind
that?
of what on the very, very far right, like memory chunk
Yeah,
selection, right? It says
yeah.
1, 2 is
I
disabled, 2,
can't really
3 is
read it at all, but
right, right,
yeah.
right.
But is that what
So
that's what it does? It tells what the
that's
jumpers
what
do?
tells you, yeah,
Okay,
right. And then
good.
here
Because
tells you the shadow ROM, yeah. So 1, 2, tells you what the shadow ROM jumper does.
okay.
Hmm.
And then there's other things on here like, TS1510 and ROM cartridge player, just kind of other features, right? Programmable joystick interface, high res support. So it does have built-in support for WRG high res graphics, 512K RAM pack and whatnot circuit. I'm calling this the 1520 for whatever. I don't know why, but that came to mind. This
That's
is my 1520.
the next
I
step.
think, yeah, after the 1510, right?
That's crazy,
And
Carl.
then, and then of course the bottom of it, like I said, kind of already saw that. But main thing there is the battery, and it comes in from the edge here. Doesn't come in on this side, obviously.
Oh, okay. I
That
was
wouldn't
wondering
make
about
sense.
that.
You push it in from the edge, the
And
card
that's
edge.
that's like a 2032 or something.
Right, right.
Yeah.
Just a standard lithium battery.
Hmm. So a couple
So of
of
course
bottom
these are
line.
keyed. These are keyed, right? And I did, when I made the original ones, the ROM cartridges can't plug into the 1510 or vice versa. That's so
Yeah.
they are keyed a little different. They're keyed uh one pin off, so they won't go into each other's cartridges connectors. So
Wow.
any questions on that? I know we don't have a whole lot of folks here, but good thing it's being recorded
Yeah.
because this is I kind of mentioned this to David, but I haven't really put a post up on the group's IO about this. So this is probably the first time anybody other than David's really hearing about this.
So, I mean, I see you haven't done the sort of bridging connectors yet. So you don't yet know if it works or not.
Nope, no, I'm still waiting. I got to order those because
Okay.
what it's going to do, I'm not going to solder these together. So there's going to be a female header and a male header.
Yeah.
And I don't know how tall I need to be, because there's, it's going to have to clear some things right on here and vice versa on this board. So I've kind of gave myself some really long headers,
Mm-hmm.
and I think this will probably be the female side underneath. So you can push the board onto the pins.
Yep. Yeah.
And that way, if you need to service the bottom board, I mean, I don't know if this ever gets into production, but maybe it'll be permanently soldered in. But I still kind of like the idea of being able to pull them apart.
Hmm. Hmm.
Unless you don't want any of this shit and you just want the joysticks and the sound. Well, the sound won't work. The
Without the
joysticks fully on this board, so that would work. But this, yeah, that's about it.
and the joystick maps to keyboard keys.
Yeah, it's the same thing that I had running at the show. So it uses it's programmable. So you run a little program to set what keys you want the joystick to react to,
Okay.
and then you run the program. And
Okay.
then, once you've programmed the joystick to the keys, it'll remember them, and then you can just start up whatever program, and then it will activate those keys. So that was
Yeah.
a big thing with the programmable joystick thing, is we obviously needed it to be able to be reprogrammed to whatever keys you wanted it to be.
Hmm.
Uh, Instead of just being, some of the older designs, they just map to certain keys on the keyboard and that's it. That's all you got, especially like the cursor keys,
Yep.
right? But a lot of programs don't use the cursor keys, so so it'd be useless.
Yeah.
So yeah, this little program, programs the
After Carl
joystick.
does his talk, I would like to hear from people who used the keyboard on the 1000 to play games because I never really had that proper experience. Like from Ryan, I have this like overlay that kind of like gives you rubberized keyboards, kind of like the Spectrum. So if I mess around with it, I use that, which it's still not great, but anyway, I don't want to interrupt Carl, but I would like to hear from people who have used it.
Yeah, it's not the greatest thing, and sometimes the response time of the machine itself is kind of slow, so that doesn't make it a good experience either. But and the joystick's not going to make that part of it any faster, right? It's just if the game is only pulling the keyboard so fast, the joystick isn't going to make it any better. It's just going to be, if you push up on the joystick, it's going to move whatever character forward or do whatever up is designed to do, right? So,
Yeah. Yeah.
I think with the keyboard response time and the kind of being slow, there's one game though where that really actually adds to the experience of the game, and that would be 3D Monster Maze, because it's kind of like, there's credited as being one of the first survival horror games, and you're just trying to outrun the thing. And the
mhm.
fact that like the keyboard is not responding as fast as you want just kind of increases the terror.
Yeah,
I mean, and even though it looks so primitive by today's standards, there is something like really unnerving about the game.
yeah, that happens to be one of my faves for the one. Yeah, that I got that when I was a kid, and I actually, you know, got scared, playing
Yeah.
that game.
I'm trying to think,
Yeah,
do I
I've heard
have a
people have jump
copy
scares
of
to
that?
that.
I did a clone of that game for the color computer as a cartridge, but I can't. I don't know. I don't have the cartridge. I don't can't find the cartridge, but I thought that game was so clever. I kind of somebody posted the original source code to it online with comments, so you could kind of see the algorithm that the blanking on his name that the author used to generate the maze. And I didn't do a reverse engineering of the assembly, but it was like you kind of got, oh, here's the gist of how it works, and then you go make your own implementation of it. And then at
Hmm.
some point later, it looked like that source code got pulled down.
Oh, okay. Yeah, and I know Paul Farrow made a color version of it for the 1000 too, that runs on his Chroma.
This chroma thing. Yeah.
Yeah, so it's a color version of the of 3D Monster Maze. Same thing, but it's just in color. It's got different colors for things. But and the fact that you can't go backwards, right? A lot of people try to pull back or hit the back
Yeah.
key, and you it won't. You have to turn around. You have to go left and right, and so that's the other part of it. But I did play quite a bit of that 3D Monster Maze at the show. At
And you played it
VCF.
at my house and you start screaming and yelling and
Oh my God.
Yeah, you have to
yeah,
play with
it's
the
pretty
Uh,
lights. You
funny.
have to play with the lights down, like you're playing
yeah,
Slender Man or
yeah.
something.
It can be tough with the keyboard. The joystick certainly makes it much better, but
Does
yeah.
it? Okay.
Oh yeah, yeah. At least you know where you're going. You're not pushing on the keys. You can
You're
just
right.
hold the joystick forward and it just keeps going forward. I mean, the keyboard would do the same exact thing, but it's just more intuitive when you have the key when you have the joystick. So
That's hilarious. So, Carl, this isn't the only thing you've been working on.
Oh no, no, we've got a lot to go here. So, all right, let's so the next project is the KiloZ thing.
Wow, that looks nice.
So this finally, I got it built up maybe 2 weeks after we got back from the show. I actually took most of the part because I couldn't remember where the hell I put the parts that I bought for the Rev1 board. I found them eventually, but not in time to build this. I just took all the parts off the original board that was working at the show, so I knew all that stuff should be working, and I put them onto this.
Just
So
make sure people know what this is, Carl.
Yeah, yeah. Talk to us about what the thing
I
is.
mean,
okay, so
I
this
do.
is this is the I'm working with Ingo on this, and this is kind of designed to go into his KiloZ keyboard, full size keyboard. Um, I mean, it's got the same footprint as a TS1000 motherboard, so it can go into a 1000 case, but obviously these joystick port and the power port and video output port, you don't have holes for those, so you'd have to modify your case. But
Hmm.
on his design, it's going to be designed for this, so it'll have those holes already there. This board will be, they're making a 3D version of the case for this board. And so basically, initially, this is the Rev.2. The first one that was running at the show didn't have some of the extra stuff on here. It just basically was a proof of concept to get the West-B, which is up here in the upper left here. Make sure that that worked. And of course, it uses a real Bronte, ZX81 ULA. It's basically a clone of the 1000 board. That's what I did, right? So there's nothing really new there. But what is new is all the little additions, right? So again, a lot of the things that I just talked about on the 1520 board came from here,
Hmm.
right? The joystick circuitry right here is identical. It's just moved over to that other one, and I know that this works, so might as well. This one does have the memory chip though in there. Um, and then of course the sound, we added that on this Rev. So same thing there. You got the decoder logic, these three chips over here. And then there's the IO port, which eventually I kind of hope, even on the other board, the 1520, maybe using this IO port to control some logic to take over from all these jumpers. So you'll
Hmm.
be able to actually control chunks and stuff like that through through IO ports, kind of like the 2068 does, right? You won't have to physically move jumpers around. You'll just do an out to a port to change it and effectuate it that way.
Hmm.
Same kind of thing with the M1 NOT circuitry. Same that's underneath the ULA. You can't see that. Um, but using an IO port to turn on and off the M.1. But that's future, right? But that's kind of what I'm thinking to do with that. But
And
this one,
Ingo's
go ahead.
case has a sort of lift-off lid, kind of like an Apple II, so that you can get access to these switches and the
Right,
jumpers and stuff.
right. So that's kind of convenient on his. And the other thing too is, this does have on the far left here, one's a programming port for the ESP32. The other one is a thin film transistor LCD port.
Oh,
So
oh,
technically, if we get the right LCD there, we could put an 8-inch LCD in that top thing
in
that
that
comes off,
panel
and then
space.
right, and then you'd have a screen too.
The
Probably need to have it.
the
What's
long
what's that?
vaunted and sought after TS 1000 portable.
There you go. With a
Yeah,
battery
slap
pack
a
in there.
exactly, slap a battery pack underneath the bottom. Take it everywhere.
Right,
Do your word processing at the coffee shop.
I think
right.
it's too
Make
big
a
for me
Ryobi
though.
holder for it.
But yeah, we had talked about that, battery, and then have the screen would have to tilt up too, right? Because it
Yeah.
needs to be more tilted up, but they can make that happen with the 3D prints. Um, but
Wow.
yeah, there's a lot going on this board. I did get it down to 6 layers, which is good because the original board was 8. Um, but so GLC PCB's got some pretty decent deals on 6 layer. They make it, they'll give you the gold plating for free. Well, not free, but it's included in the 6 layer.
Yeah.
Um, So that's kind of nice. But anyway, there's basically a duplicate of what was on the other, the 1520. You've got the amp chip down here in the corner. This ear monitor switch is kind of it's just so because it right under the Ferranti, the ULA here, there's an ear input and a mic output, right? So you can have ear and mic jacks on the, whatever you put this in, right? So that's still available to you.
Is that
And
what
the
those
ear
two white things
monitor,
are?
right, these
Okay.
two white headers, right?
Okay.
That's the ear and the mic jack. And the ear monitor is so it'll actually feed the ear input through into the amp, so you'll be able to hear it.
Carl, don't you want to put that switch in, the real way where it mounts on the bottom of the board and pokes through the bottom of the case?
Yeah, maybe. We'll see. That was just kind of, let's see, I'll throw that in there. What the hell? I was thinking, maybe you want to hear it, kind of like the 2068 does,
Hmm.
when you hear when the loading happens. But you can turn that off too, so it doesn't make any noise. And then of course you got the volume pot over here, and this is a video pot for the ESP32.
Does
Kind of
that,
another, go
sorry,
ahead.
does that volume pot line up with one of the you know, jack holes on a 20 on a ZX81 case?
I didn't plan it that way. It might
Okay.
line up to the, you know, and then eventually, like I said, maybe I might want to do that digitally, right, with this I/O port.
Uh,
So you'll have digital volume. We're getting kind of high
so
tech here for
so
this 40.
you would use the extremely slow keyboard response to turn down the volume while your mom's yelling at you. Okay, got it.
Yeah, exactly. Or maybe we could have like a up down buttons that are physical.
Hmm. Hmm.
And of course, this ESP32, I didn't use the one that has a lot of them have a built-in antenna. I thought
Hmm.
that maybe the case shielding might cause the problem, but apparently people are saying no, it doesn't. So anyway, the ones I bought have an external antenna. And that's kind of what you see going off there. That's an external Wi-Fi antenna.
Okay.
And then this jack on here on the top is this is the VGA video output and power input,
Oh.
right? So 9 volts comes in on this, and it's got I need parts for a dongle. I'm making a dongle for that, so I want it to be because I kind of had a rinky-dink one at the show. It worked, but it wasn't that pretty to look at. So I want to make a real dongle for that has jacks and all that stuff on the output. So it'll be
Hmm.
much more professional plug that in. And then kind of right next to it, another white header you see right here.
Hmm.
That's the power switch. So if you have a
The,
power switch, you can
the,
plug it in there.
the what?
What's that?
I'm sorry, you said a what?
A power switch.
What is that?
I was
Yeah, we
going to
don't.
go there too, David. I was going to go there too.
So right now I just have this shorted out on the bottom
Hmm.
because I don't, I don't really care about that. But anyway, it does have the facilities to hook up to a real power switch.
Hmm.
Next to that is the jack. This is the audio jack, similar to what was on the 1520, but this also has a composite video out. And
What?
this kind of uses the
Really?
same, yeah, it kind of has the same. I'll talk about another project further down, and I still have Adam's 2068 here because we had some joystick problems on it when we were testing some things out, and so I designed a replacement little board to give that 2068 stereo sound. So we'll talk about that later. That's
Okay.
also in this presentation. But anyway, so this
What else
uses the
can I get you to
same.
upgrade?
Yeah,
Just let me
right.
know. Let me know.
So this actually has left audio, right audio, and composite video output. Right? There's a little dongle that's pre-made that I bought, like 10 of them or something like that. But you can buy it on Amazon. That's where I got it, and it'll plug in there, and it goes to the right. It has the right pin out for that. So you can have composite video out for this, or you can generally, you probably, why do that? You would want the VGA,
Yeah.
right?
Well, I have a
Um,
question about that. Like on some systems, like the Atari, and for instance, you'd get black and white color on color games if you like use superior like VGA output because they were like artifacting the color screen. I mean, you only have black and white, but did anything try to use grayscale or anything to do on the Timex
Well,
1000?
you do have, well, you don't really have grayscale, but you do have some of those graphic characters that are kind of show up as gray, the
Oh,
little,
I see what you're
Yeah.
saying.
you
Which
know
would
what I'm
probably work
saying?
better in composite, right? Because it's more fuzzy, or even on
Probably,
a
yeah,
TV or
right,
RF.
right.
Let's use the
Well,
worst
don't
signal
forget,
possible.
yeah, don't forget the ESP32 actually samples the video output from the ULA and recreates it in VGA. So it's not like it's, converting the video output directly to VGA. It's actually sampling, what video is coming out of the ULA and actually recreating it in VGA. So so it's very, very crisp. I mean, it's great video output for this thing, no doubt. Although the video output of even on composite wasn't that bad to begin with, but like you said, it's only black and white.
Right, right.
So okay, so then kind of, to the right of that is the joystick port, obviously, and then you've got the expansion connector here,
Hmm.
and
Hmm.
kind of under the joystick, I got these two LEDs in here right now. Normally, that's a header, so you can go off board and have the LEDs in the case, so you can tell M1 status
Oh,
if you have M1 not on or M1 not enabled or disabled. And this is supposed to be a single LED. I'm thinking in the case it would be just a single bi-color LED, not
hmm.
two physical LEDs. But I just had these around, so I threw them in there. So it'll be one LED, but it'll be red if M1 not is I want to say enabled, and in green if it's disabled. So you can kind of tell. And that's what these two switches are here that are kind of in between the Z80 and the Ferranti. Although that would actually go to a single, a double pole, double throw switch, right? But these are just single pole, double throws. But that's where the headers would go to a double pole, double throw switch. Got
So
it?
and your holes in the board line up with the, standoffs in the case, the ZX81
Right,
case, right?
right.
So if one were, handy with a Dremel and had a bunch of 81s or 1000s laying around, you could theoretically shoehorn this into, you know, the real deal.
Right.
Okay.
You could. Yeah.
Okay.
Now I have to say these two holes over here on the left side are a little off. I haven't quite got them right, but and then Ningo was like, don't worry about it, man. We'll just 3D print to whatever holes that you got on your board.
Ah,
So I'm like, okay, well, and I know these three up here are direct. I mean, they're spot on.
okay.
So, but these aren't quite. They're a little bit off still. I tried to fix that in this rev, but I guess I still didn't get quite close. So,
Is there somewhere a two-pin header for providing power?
deriving power.
No, put providing power to it. So
Oh,
if you
providing
didn't want to
power.
provide power through the combined VGA power connector.
No, not really.
Okay.
So, I mean, you could put it into this power header, but you need to
Oh,
put ground somewhere. Ground
uh-huh.
it to
Something.
there's all kinds of grounds here, but so you could do it that way, I suppose. But
Okay.
yeah, there's not a header directly for straight in power.
Okay. Oh.
Is there a
So how far have you gotten in terms of testing this one?
Well, I'm waiting for the parts to come in for the dongle, so that'll be the final thing. So once I
Okay.
get that in, I definitely kind of wanted to get this tried out because I've had it built for a couple of weeks. Of
Okay.
course, there's a header down here. Well, there's an LED in there, but there's a header supposed to be there for a power LED.
Hmm.
So if got real Commodore 64 vibes with the little power
Oh,
LED up, right? You can have the same thing with the 1000.
nice. Is that an LED over on the far left by those pin headers?
Yeah, that's like status of the ESP32. That blinks and does things when the
Okay.
ESP32 is working.
Okay.
So kind of just gives you a make sure the ESP32 is alive.
So you could have a whole bunch of blinking lights on your computer.
Yeah, it'll be interesting when I get this up and running and see what's all going. I mean, I'm used to this one because I see it on the, the one I had at the show and the
Yeah.
one I did all the troubleshooting and testing on. So,
But under normal
uh,
circumstances, all these lights would be blinking in a case.
well, they'd be external, so you could see them.
Oh,
The power LED would be external, right? The M1 not LED would be external because you need to
okay.
kind of see them to know the status, right? I mean, this one probably wouldn't be external, right? That's just, I mean, I don't even know if you would populate that once it's running. I mean, once you know it's running, why would you need that?
Yeah.
So, so this I don't intend to ever be outside. It's just kind of more, just so you could see that, not really a heartbeat, but I mean, when the ESP32 does things, this thing blinks a lot sometimes and slowly blinks other times when it's just kind of doing nothing. So it's kind of like a heartbeat thing, I guess, for that, right? So the ESP32 is working.
Hmm.
Because otherwise you wouldn't ever know because when you power this machine up, it just powers up to a K cursor, just like a 1000 would, right? You have to actually hit load quote quote, and that kicks off the ESP32 software, right? So then the ESP32 menu will come up after that, right? So it doesn't just auto boot. Although I guess we could change the code in the ROM to maybe make it do that. But anyway, as of right now, this ROM chip is, I got these from Stuart. Stuart provided those, thank you, Stuart. Gave us like 5 of these ROM chips. These are just, the ZX1000 ROMs. So, because they're different, right? You can't, and I probably have to change this board design to use like a EEPROM or a flash chip there because, these 8K ROMs are, they're mask ROMs or they're one-time programmable. And I think it's like a 2332 or something chip. So it's a different pin out, right, than you would normally get for an EEPROM chip. So it would have to be redesigned there a little bit to use a flash chip, which eventually we'll probably do. But for now, I
Yeah.
just wanted to use the original chips that were out of the 1000, other than the RAM chip. 2K is just not going to cut it for this. So and I'm trying to think what the hell is this header for because I got everything around. I can't. Okay, this is the reset header. So reset button, you got a header for it. So you can put a reset button on the outside of the case, which I think the KiloZ already has. He already has a reset switch on the back. And so it would plug into there so you can reset the machine without having to turn the power on and off or whatever. All these
Carl,
not all these niceties, man. I mean, what the hell?
um, that those keyboard connectors. I know, I know they used to be made by Amp. I don't know who makes them now, but where did you get yours?
I think I got these from Stuart again. He
Okay.
sent me, a few sets of them.
Uh, I know I've ordered them from either Mouser or DigiKey, but I'm kind of drawn a blank on which one I ordered them from.
Hmm.
Um, but yeah, Evan, they're well, within the last 10 years, I was able to order them in the States.
Right,
Yeah, I just
right.
don't know what the part number is.
Yeah,
I
that's
search
what
up for Molex keyboard connector or something, and I
yeah, I
can't
don't
seem to
think it's
find out. Um,
Well, and this is backward compatible, right? So this is kind of made so you can plug in, a keyboard from the case. On the Kilo Z, we don't really need this. It's probably just going to be header pins, because he's got his own full size keyboard, and we don't have a flex cable, right? He doesn't have a flex cable, so it would be actually plugging into, you know, like a regular pin header.
yeah.
But luckily, those things are on, zero point 0.1 centers, so it's the same thing.
yeah. So I've been working on my ZX81 or ZX80, whatever it is. It's kind of both. Kit from Vintage Computer Fest, and the parts have been slowly trickling in, and then and then I have the nice clicky keyboard that Stuart supplied to me that comes with these
Mm-hmm.
little tabs that you solder onto the edge of the cables, but then I don't have the sockets, the little connectors to go into. So that was the use case there.
Yeah, yeah.
Oh, okay. Okay. Yeah, I know he's got little PCBs that kind of have the fingers on them that you plug into these.
Yes, yes. So I
Yeah,
need those sockets, or I have to find those sockets somewhere to get the little headers to fit in there.
right, right. I know they're available, like David was saying, but yeah, I don't. I like I said, I'm gotten lucky with
Oh,
Stuart sending us stuff. So
okay. I could just email him and ask him what the part number is, or
yeah, I don't know
Um,
that he would know that, but yeah, and you know, but maybe David can look it up because if he's ordered them in the past, then
I
maybe
have.
he'll.
Yeah.
Yeah.
It'll take me a few minutes, but I'll find it.
okay.
Okay, so going on with this thing, a lot of shit on this board. So, a lot of the circuitry is just, stock TS1000 stuff. Again, it's got a 512K chip memory, so 8 64K blocks. These are the same kind of jumpers that were on the other board, so you can enable or disable whatever chunk, including the shadow ROM. Right, has the same memory decoding circuitry, which is actually underneath this chip. You can't, so you can't see that. Um, And so that's kind of the memory side of it. So at least with this, you have the full, 64K of RAM. And then of course there's the battery backup down here again, right? And you push the battery in from the bottom edge. And I did try this in a 1000 case, and this chip kind of gets really close, the sound chip, because it's in a socket, right? And it's in a socket just basically because for prototyping, right? Just make sure everything's working. But it will definitely fit in a 1000 case if this thing is soldered down on the board. It just bare. I think it kind of touches on the edge of the not on the pins, but on the edge of the top of the chip there, barely. Maybe. So then there's that weird speaker that Adam kind of doesn't believe is a speaker. So this does make sound, or hopefully should make sound. And so yeah, that's kind of this whole thing. And I don't know if I have a okay. I kind of had some close-up shots of the sides, but I don't think we really need to. And of course the back. I haven't cleaned any of the flux off, so don't give me any lip about that. I don't really care about that on the prototyping stage here. Um, I guess there is this chip on the back underneath the sound chip. That's again the clock um, that regenerates it slows the clock from the main clock, the 3.25 megahertz or whatever, down to 1.6 something, basically puts it in half.
Yeah.
And of course, you've got your ceramic oscillator here that I had to buy 100 of these from China because the new ones that I got from Mauser, they just don't work. I don't know what's different about them, but these are the same identical ones from 40 years ago, but I just got 100 of them for like, I don't know, $5 or $10. But they work. So that's their CTS parts. So that's what came with originally. That was one of the problems I had with the Rev 1 board, or the point 1 board, is after I had it all together, it didn't work.
Wait, I thought
And
this was like the point 1 board, like
no, this is the point 2. If you see down here, it's Rev 0.2A.
well, I can't read any of that actually, but
You can't?
no,
You need a bigger monitor, man.
Yeah, yeah.
it's, I guess.
Plus, I have a bunch of, I give credit to everybody. I'm not trying to take anybody, credit from anybody's designs. This is all, basically I just copied their designs and put it all together. And of course, long live site, actually when we were at the show, that's when he died. He died on the 16th. And I was looking at that after we got back in the show. I was like, oh man, we didn't realize that he
Oh,
had
that's
passed on the
crazy.
16th,
Yeah.
and we were at the show. So, but this, yeah, Rev 1 board, the point 1 board uh, it was running really slow for whatever reason. That it's a 6.5 megahertz, ceramic oscillator, but it was running at like, I don't know, 2 point something. Maybe it was getting too loaded down, or something like that. But no, the video in this machine is based off of this clock. So being so low, that's why I wasn't getting any video, because it was just the video was frequencies were way different. So I mean, it was running, but it was just running too slow.
Hmm.
So I was like, so I just took a ceramic oscillator out of a real 1000, threw it in here, and then bam, there you go. It worked. So I was like, okay, well, I'm gonna have to get the original part then. I mean, eventually, maybe we could just redesign this so it uses a crystal instead of a ceramic oscillator, and just go with that. But anyway, all right. That's man, I'm sorry I'm taking so much time, but I mean, I guess Jeff's not here, so he won't be able to talk too much about the 2060. But
True.
I just I don't want to, but I do have a lot. So, and this is recorded, so this will kind of be keep me honest.
There you go.
Okay.
Oh,
Any questions on that before we go to the next?
no.
Are you gonna come over here and share it with me and show me?
Yeah, we can
Okay,
make
let's do
videos
that.
of it, man. Yeah,
Yeah.
yeah. Okay. So the next thing is kind of been working on the last week here is this. Well, I've been working on it for a long time, but I'm finally getting around to actually doing this. And this is an external drive for my Spectrum Plus 3, right? So this is the actual drive that came out of the Plus 3, but I bought a GoTech to put into the Plus 3, so that the Plus 3 will actually have the GoTech in it. And but I noticed on the back there's a drive B expansion connector. And I was like, well, that's kind of cool. Maybe I can still use this drive, even though it uses the 3-inch discs, not the 3.5. It looks like a 3.5-inch drive, right? But it's smaller. It's a little bit smaller. So it uses those CFO1, 3-inch discs. But this is that drive in a 3D printed. Somebody came up with this little 3D printed external enclosure for this drive, which is kind of cool, right? So that's with it in there, and then of course this is the back. So, and I had to design a PCB that goes in here. You're seeing the 34 pin edge connector there for the IDC connector, and then you got an A and B switch here. So you can, I guess, switch it to a drive or a B drive, and then of course the on-off switch, and it takes external power. But I'm going to wire up my plus 3, and I made some provisions on the circuit board so I can throw 12 volts over the ribbon cable. So
Hmm.
I shouldn't have to need external power to run this. It'll all be through the cable, which I kind
Carl,
of
since
prefer.
I don't really know much about the plus three, like I know it could use the 3-inch drives. Could it use like an external one too? Was there a connector on it to have one, or was it
Yeah,
only in,
that's what I
yeah,
just mentioned. Well, there's a drive B, it says on the back.
right. But
So,
like
but
that
the
was
A came in it. So the
and
A
that was
was
part of the
always
OS though,
right,
it
Yeah.
was okay.
right,
Yeah.
right. Yeah, it was built in, the drive was built in.
Right.
So, and then you can, well, you can, if you put it in 48K mode, of course, the drive wouldn't do anything because the original Spectrum didn't have anything for it. But if you booted it up in 128K mode or the plus 3 mode, obviously the drive would work.
Okay.
So, but anyway, I kind of want to get into the inside here. This is kind of a test fit of this board because there's very little space, guys. Holy crap.
Yeah.
um, and so I kind of had to get creative with how my connectors are going to go. But there I have more pictures here. So this is the board actually in the back of the 3D printed case. And so this power connector, that just looks like a regular floppy power connector, right? Well, this actually came off the drive itself. I just soldered that and put it on here because if it's on the drive, it sticks too far back. So I'm going to have to swap stuff.
Oh,
The disconnects are going to be on my board, not on the floppy drive, right? The floppy drive will actually have hardwired connections that'll go to these connectors.
Carl, I'm sorry. I just caught on to this. You 3D printed that case?
I bought it. Well, I sent it out to be 3D printed for me.
Okay.
Yeah,
Interesting.
yeah,
Interesting.
yeah. I didn't. Somebody else designed that.
Okay.
You can find it on Thingiverse or one of the other sites.
That's fascinating. I'm
Um,
curious. Can you go back to your picture of the disk drive? What
which one?
mechanism? Oh no, the drive itself. That one there. Yeah. What mechanism is this? Is it an
These
Intel?
are, I think, Panasonics.
Panasonic.
Yeah, it's a
Oh,
Panasonic drive.
a 3-inch.
Mm-hmm.
Wow.
Or
Okay.
Matsushita, Matsushita, same thing.
Okay. Okay.
But yeah, it's a Panasonic drive. And they made like 4 or 5 revisions of it. You can go to the CPC, Amstrad CPC site.
Okay.
They explain all the different versions of this drive.
Huh.
So,
Yeah, from my understanding, the F floppy disk system that Portugal made used just Hitachi drives.
mm,
Um, which I don't know. I don't know who came up with a 3 inch, drive, but yeah, okay. I
yeah,
didn't know that other people made it.
yeah, I think it's probably the same design. It's just, Hitachi made the drive instead of Matsushita. So,
Yeah, yeah, yeah.
yeah, yeah. So,
Mine look crustier than yours. They're older too.
but this is kind of a top-down view on that board
Oof.
because I had to sandwich 2 boards together, right? So I had to make 2 separate boards, and they're soldered together with a header. Um, I know that's kind of I got the flash on, so it kind of looks a little blown out, but this is looking at the bottom of the board. So you got a regulator that's over here for 5 volts, right? Because it's getting 12 volts either from the external jack or from the computer. Depends on what you're doing there. But you need 5 volts. There's no 5 volts that comes across
So
the
if you
connector.
had like most of the parts of an FDD system, if you had the twister and the little doodad that plugs directly into the computer, and I'm trying to think what else. There's the power supply, and then there's the sort of controller unit. You didn't have the disk drive. You could theoretically use this to get a disk drive for an FDD, huh?
Or which FDD? The
The three,
3000?
the three, with
Yeah,
their
I'm not.
individual plastic boxes.
Oh, yeah, I'm not familiar with. I don't have that, so I don't know what's inside those.
Hmm.
I imagine it's the same drive, right? The 3 inch
Hmm.
drive.
Hmm. Yeah.
But all the hard drive circuitry obviously is on the motherboard in the plus three, right?
Hmm.
So, and I think it's a
Hmm.
Western Digital, 1771 or something like that they put on
Hmm.
there.
Yeah.
So,
Wow.
which I know Charlie, in New Zealand, he has an FPGA version of that to be Western Digital chip, probably because of this plus three or the Amstrads. The Amstrads used it too, right? So,
Yeah.
since I don't think you can really get those anymore, he made an FPGA of it. This is kind of looking at the back of it, and you can kind of see so these 2 connectors, like I said, the power connector and the interface connector actually are off the drive. So I took them off the drive and put them on my board
Hmm.
because that makes the drive just enough shorter, right? So I have to hardwire, wires to the drive so that all this will fit in there, man. It'd be nice if they made it just a little bit longer, but whatever. We gotta. I'm not going to go and redesign the case for this. I'll just have to figure
Well,
something
maybe
out.
you
But
could ask the person to redesign the case,
yeah,
whoever designed it.
maybe,
Yeah.
and I don't know what they had in mind when they were. Obviously, they had the hole cut out for the connector to plug in, but I don't know what board they were using. Maybe I could have made all this on one board. I guess I don't think I could because there's not that much room, even height wise. Um, but anyway, and then again, this kind of shows the drive in there without my board. So you can kind of see how much space you've got there. It's not really a lot. And you
Yeah.
can kind of see the holes. This is where the interface connector would go, right? You can see the holes there, and the power is over here. So those are the desoldered holes.
Wow.
So that kind of makes the drive just that much shorter. And then this is with it in, I should have rotated it, but
Super tight.
yeah, that's with the board in there and the drive in the right space. So it's really close. Especially the stepper motor here is really close to the top of that. And I'm gonna get a IDC connector for this, but I had to find I've got about 5 millimeters of height there
Mhm.
before it hits the bottom of this motor on the bottom there. Basically how high this connector is, right? Because this is what was there
Right.
was this IDC connector here. And they hardly make. I think one company makes one that's 5.5 millimeters tall when you have the ribbon cable pushed in there, compressed. So it's like 5.5 millimeters. Can I get away with that? I think half a millimeter might be okay. I might have to shave a little bit down where the roundy part goes, but I don't know. I'm going to try that. I'm going to get one of those. That way, not to solder individual wires into all these. I'd rather, have a
Just
IDC,
a cable.
connector that can I solder down in there. Yeah, the cables, it can't unplug. It's captive, but the other end will be up here, which will have the disconnectable part, right?
Yep.
The
Yep.
And then the power connector, I don't mind soldering the wires onto that. That'll be fine. And then they'll just run over to this, power connector. So the drive will still be able to be taken out, right? It won't be like a pain in the ass to service this thing, but it's a pain in the ass to get it all together. I guess I'll put it that way. So anyway, hopefully some of this is kind of cool to you guys. I mean,
Are you
this
going to
is
use this, Carl? Like, I mean, do you have a
I
use
plan.
case?
I plan on it. Yeah, I need to
Okay.
get some floppy disks. I've been looking at getting some floppy disks because I don't have any floppy disks for this thing,
Okay.
but they're still available, so it's not like they're not that hard to get.
Yeah,
And then
they're a little
go
hard to
ahead.
find.
Yeah, I mean they're not bad. You can get, especially overseas, are easier to find.
Yeah.
In the U.S., they're kind of hard to get. Yeah.
Yeah. There
And
were
then of
some
course
weird
this is a
systems.
picture of my
Well, in the
plus
US,
three.
they were only used in typewriters or something, right?
Yeah, like word processors. There was some
Yeah.
weird word processors that used
Yeah.
them, I think. Yep.
And so this metal, this is actually a metal plate, this 128K FDD floppy disk drive. So there's a little cutout, right? A little recess in the case here where they put that in. And
Hmm.
so whoever made this 3D print, I go back, you can see on the top,
Uh,
it's got a little recess.
nice.
And so that's exactly the same size as that. So you can, either buy another one or make up your own, and it'll fit right in there. That's what it was meant to do. And I guess the depth of the drive is basically kind of similar to the depth of the plus three. So
Oh,
I guess that's probably what they were looking at. So if you put it next to it, it wouldn't be any longer, right? It would be right up against it. So, or it would be the
yeah.
same dimensions as the
Something
plus three.
reasonable. Yeah. Interesting.
So the other thing I wanted to bring up here, since maybe
Oh, Carl, you're kind of cutting out.
oh, am I better now?
Yeah.
Okay. Um, bring up, since a lot of you guys probably haven't seen a plus two or plus three, is notice on the keys, right? There's some
Hmm.
keywords, but on the rest of the keys, there's no keywords, right?
Yep. I see
Which
the
on the
important load,
right,
code,
the right, the
run.
important ones are on there, but the rest of them, because if you're normally using this in 128K, you don't, you can type them in. You can type print.
Oh, yeah.
You don't need the keywords, right? But if you're using it in 48K mode, obviously the keywords are going to have to be there. So, but they didn't put them on this keyboard because I think they kind of reuse this from the Amstrads, and they were figuring, well, who's going to use it in 48K mode anyway? But I just kind of go
Yeah, I
ahead.
see they took their design cues for the location of a reset button from the Apple II and put the break in the upper right-hand corner instead of, say, something reasonable like delete.
Oh, yeah, you would think delete would be right there, but
No, break. I mean, at least it's not a reset button, so,
right, that's true.
Ugh.
Delete's way here over where the tab button would be, I guess.
Right, because it makes sense for it to be a tab button. Yeah, absolutely.
Oh man, extend mode is like, I don't know. Yeah.
That's weird. Oh, that's extended where the control key would be. Wow.
Yeah. To get
Wow.
it into extend mode so you don't
Well,
have
That
to
is
you
do
have to
crazy.
admit it does have a space bar, unlike a space key.
Yep.
So that's good,
Mm-hmm.
yeah,
right?
yeah.
Yeah.
Mm-hmm.
It's
Yeah,
kind of
there's
fun to
a
look at. I haven't actually tried this out yet because the power supply that came with it obviously is a, UK or
Oh, did you
whatever
just get
cheap.
it recently?
It's been a couple of months, yeah,
Okay.
but I'm making a modern power supply for it too. So
mm.
It's a switcher inside, and it'll all fit inside the original case of the one that it came with, but it'll be, universal, right? It doesn't matter what voltage you use. But
For my Spectrum, like right before Radio Shack closed out, I went in there and I asked them if they had some sort of, it was for a Spectrum. It was a center negative 9-volt power supply. And they said, no, we don't have anything like that. And then I looked on the wall and they had exactly that thing. It was a travel power supply with all these adapters, and it had a
mhm.
switch that would go between center negative and center positive. And it was like, oh, well, I'll just take this then. And so, like, I don't know if that would work for you.
Well, this uses the DIN plug, so you'll see on the ports when I show the ports. But the other thing Radio Shack had was adapter plug, right? They had the
Yeah.
adapter plug stuff, and you could actually just rotate the adapter plug and plug it in. That would reverse your polarity as well.
Oh,
So it kind of depended on how you wanted that. So yeah, let's talk about the ports.
Oh boy.
So on the ports we got tape and sound, which looks like that's the 3.5 millimeter, like a headphone jack. The TV output, which obviously in this case will be UHF PAL, and then you got the nice RGB video output there, which is I'll have to get an adapter for that. And then you've got the British Telecom connectors that they use over there for their RS-232 and the aux port. I think
It's
the aux
also
port,
MIDI. What is that? Like,
I
is
guess
that?
so. Well, that's music, right?
Yeah, I know
Music.
what that, but
Yeah, yeah,
okay.
yeah.
So I guess
Uh,
there was probably a lot of software for it that was written to con
it could be, yeah,
There
yeah.
was
Well,
some MIDI software
was
written
there?
for the
That's cool.
Spectrum. It was bizarre, but yes. Yeah.
and I guess the aux port, I know one thing they kind of used for that was a 10 key, a separate 10 key keyboard
Oh yeah. Hmm.
that plugged into the aux port. So, and then on the other side here, there's the expansion, the regular, there's your power supply connectors. So you can see the DIN there.
Hmm.
This thing takes, I think +5, +12, and I think -12 or
Really?
minus, what
Minus
is,
five, maybe?
what is the mean well that I got? I got the mean well. It has the 3 power. I think it's plus or minus 12 and +5. That's pretty much what it takes. It doesn't take -5,
What parts? Oh, the RS-232 needs plus and minus 12.
probably. Yeah,
Yeah.
right. And of course, it has a printer port built in, which is kind of nice. Centronics printer port, which would be cool if
Oh.
we had those on ours.
Hmm.
And then there's the disk B expansion port there for the external disk drive, which I plan to use.
Very
And
cool.
I actually have a box. It's a
Wow.
beat up box, but and the styrofoam's inside too. So a lot of times you don't get a box with these things. You don't even get the styrofoams. You just get the computer, right? So it
Yeah.
wasn't cheap. I think I paid $300 for this thing. So
And this is like 86. When is this?
yeah, right around there, 86, maybe 87. This was the last Spectrum that
Hmm.
Amstrad had Sinclair at this time. So that's why, this is their design. Their CPC computers look pretty much like this.
Hmm.
Okay.
What do you have about this stuff on your own site, David? Or is it you just let
I don't
other
cover
people
the UK stuff at all.
that period?
But because the UK
Because
people
I know
have
there's a million sites that do.
they've got it covered so well, there's no point in
Yeah,
me, bothering.
right.
And really the site is about us in America.
I understand that, yeah.
Yeah. What's this, Carl?
Okay. Next project. Not that I didn't have enough already,
Not
right?
that you don't have enough already. Oh my God.
So, and you can kind of see this board was made back in February.
Oh, I
So
remember
what this
this.
is, yeah, what this was is I actually was making a perf board version of this, and I'm like, you know what? Now that I know how to make boards, I'm just going to make a PCB for it. Fuck the perf board. That just was painful. Um, so yes, so these are special relays, which are kind of cool. These are set and reset relays, so they're latching.
Okay.
If you latch them set, then they'll just stay there, right? They stay set. If you push if you power the reset coil, well, then it pushes it to the other side, and I guess they call it set reset, right? So
Hmm.
basically, though, it just latches it, whatever position you put it in, it stays there until you switch it to the other position. And these are kind of unique relays. Luckily, I think I got about 9 of them because I got 5 of these boards. You get 5 boards, so um, I think I could build 3 or 4 of the boards up. But anyway, um,
So
see
this,
these relays have 4 relays inside.
I don't think you actually said what this is for
yeah,
yet,
yeah. Tell us
even though
first what
it's
it
labeled.
does. The whole thing.
Okay. Okay. So this, as you can see on the writing here, is the Timex
Yeah.
Sinclair 2050 or the Westridge. It's an RS-232 / modem switching module. So this will allow you to either use it as a modem, the 2050 as a modem like it normally comes, or there'll be a switch on the back where you can switch it to an RS-232 port. And that's what this big thing here, this will be a DB25
Yeah.
serial port, right? So you can connect this up to like an external modem, like a 33K modem or something. I don't know if the 2068 will run that fast, but you could hook it up to a 1200 baud modem. That certainly would work, or 2400 baud, something faster than 300 baud, which what the 2050 was.
I have a question about that because last year I participated in the BBS thing for the Atari computers, and we used I like I can't get analog anymore. Like and like because my house I've got it in the house, and if I wanted, it's expensive to have. I don't want it just to have a modem, so I got it. You can hook up your modem through your my wireless network, and like do it that way. But the fastest speed you can actually get is 300 baud.
Oh,
So
really?
yes, and from what I understand, like you have to get away from modems, period, because all the switching equipment is all won't support it anymore.
Right.
So I don't. I mean, is that right? I don't know really. Haven't explored it enough.
I
Yeah,
do
I don't
believe
know.
that the phone network is um not supporting analog
These fast.
signals as much anymore.
Okay, that's what I thought.
Yeah.
What were you showing us, Evan?
So it's like it's a Wii modem 232. I forgot the exact name of it, but it's one of these things that the computer thinks that it's talking to a modem, but it's actually being translated into Telnet. So over TCP IP. So you can actually do BBSing with one of these things if you just have the right serial adapter. So I can plug this like straight into the back of an Apple II serial port and then start BBSing with it. And I've got it going with IBM original IBM PC. I've seen people do this with K Pros, like basically
Wow.
anything with a serial port.
Hmm.
You can
Hmm.
start doing BBSing, and now you don't have to worry about like I don't have an old school phone line.
Right. Oh, you should put that in the chat. I want to maybe
Yeah, I've seen
Oh
they're
yeah, I
basically like
mentioned it. I think it's
Wi-Fi.
like a yeah, that's what
Yeah,
it
they're
is.
basically like a Wi-Fi modem.
Yep.
okay.
So
Yeah.
yeah, that you connect it up to your network, and then you can get to the internet through it.
But like the
But
BBS must have to support it then, or because there's BBSs
well, you
around.
well it connects to the computer, and then the computer thinks it's a serial, thinks it's a modem.
Right.
It just converts it all, inside that module, and does all the magic to get it onto the internet.
I mean, you're typing old school Hayes commands, like,
Hmm.
Right.
ATDT,
Yeah.
and then it's like an IP address instead of a telephone number.
Okay.
Yeah.
Yeah,
Yeah.
so a couple of things. One, if you go to Veronica Says website, she did one with a Commodore where it like, shows you how the whole thing works. There's at least, some other YouTubers I'm sure have also covered how that works. I also wanted to point point out that the phone line thing is entirely depends on where you live.
Yeah.
My mom still has an actual POTS phone line. Um, so in Columbus, Ohio, at least, I can tell you that you will pay a lot of money for it. They're up to about $50 a line now, a
Mhm.
month.
Yeah.
Um, and it used to be like 30 or 35, but you can still buy one.
Hmm.
Well,
So anyway, what this would do, this would be
Right,
nice to
sorry.
connect. Yeah, no, it's a good segue because this is a serial port, on the back, right? What it converts it to. So you could connect to one of these Wi-Fi modems, serial modems, and get the 2068 onto the internet that way, right? But you need to have an RS-232 port somehow, either through this or another external device or whatever. But this just uses the chip that's already in the 2050 modem, the UART that's in there, um, instead of going into the modem circuitry, it goes out to the DB25 port as an RS-232 port.
Yeah.
That's why you have the Maxim chip down here. This is kind of a bigger one. This is a 237. Most people use the 232, which only has, I think, 2 transmit and 2 receive buffers in it. This has, I think, like 4 buffers and 3 transmits because I needed a few more, CTS, RTS. I can't read what on the other side of the modem, and then on this side of the modem too. So there's 1, 2, 3, 4, 5, 6 lines that I run into the 2050 over from the RS-232 port. And then, so the this chip allows me to do it all in one chip. I don't have to use 2 232s or whatever. So that's kind of why that's there. These are kind of hard to get to because I don't think I make them anymore, but they're still out there.
Mm-hmm.
And of course, on these 2 poles of the relay here, it says LED ground and LED 9 volts, and then a little current limiting resistor there. This actually will go to a replacement. The 2050 has a LED in the front. Granted, it's only a red one, but I want you to replace it with a dual color one, but still square, the little rectangular size that they had in there. And this way, it'll still work as a 2050 modem light, right? Or when you do it in RS-232, it'll change it to green. So that way you'll know, oh, I'm in RS-232 mode, as opposed to being in 2050 mode. So that's how you could tell from the front, right? So there's this switch right here, the set and reset switch, which will swap the relay, which will swap the LED colors, and in addition to the other RS-232 lines, right? It'll take them away from the modem and just throw them out the back, or it'll throw them into the modem circuitry. And this is designed to sit right on top of where the chip would be on the 2050. As you can see, there's like a socket here, or you can just solder the INS 8251 chip directly onto here, and then you would run some headers down to the board and solder this to the board.
Yeah.
Right.
Zebra made a similar thing, but with fewer parts, going to a 9-pin connector. And it was kind of, well, because these modems, and especially just the board itself were available from a bunch of vendors at one point,
Right.
and you
Right.
could easily do this. You can, just take that little adapter. It was much smaller and, more
Right.
80s,
Of course, this is intended to go inside of a real 2050, so you'd have to cut the back, you have to cut a hole for this
yeah.
DB25, but that's all you would really see. And the switch, right? You would need a toggle switch, a momentary toggle, left or right,
Yeah. You could
So,
invest in that tool for cutting DB25.
yeah, that is expensive.
Yeah,
But
yeah.
anyway, I kind of wanted to,
wait,
that's
there's a special tool. No, you're lying.
No, no,
Okay.
there
no,
is.
no,
Yeah,
there
yeah.
is
It's a
the Greenlee makes
Greenlee,
most
thank
of
you. Yeah,
those.
you drill a
Yeah,
hole in whatever it is that you want to punch this hole in, right? And the 2 pieces go on either side of the material, and there's a screw that you just tighten the screw, and it just sort of punches
right.
its way in.
Okay.
Yeah. But
Okay.
I was being facetious because, like I
I
said,
understand.
Yeah.
it's
Yeah.
very, for one shot, it's super expensive. If you're doing it,
Yeah, they're like 300-400 bucks for one of those.
yeah.
Yeah. And this is plastic in the back, so it'll probably be pretty easy to cut it. I've got an ultrasonic knife, so those things cut through plastic pretty good.
Do you have an ultrasonic screwdriver, Carl?
Not a screwdriver, but a knife.
I,
No
I think
Doctor Who references.
yeah, I was gonna say, didn't Dr. Who have an ultrasonic screwdriver?
Doctor Who did have an ultrasonic screwdriver. I guess I could use it as a screwdriver, I don't know what that would do for you being ultrasonic, but anyway. Anyway, so that's another project that I kind of, this kind of went way back on the back burner, but then I saw some of these boards and I took some because this is a Rev B board. Because my Rev A board, I had these uh, pins reversed. I think I had the chip on the left side and the socket on the right, and so they wouldn't line up. It wouldn't line up to the board.
Oh.
So I swapped them around, and that's what the B board's for. So I brought some A boards, and I think I might have gave a couple away. Just what am I going to do with them?
Yeah. Cool.
Next project. Okay, now we're starting to get into some color computer stuff here. And this is an Adams computer, by the way. This is just some other 2068 I have, but this is kind of showing up here. This obviously still has the composite jack underneath it. I mean, I just laid this on top of it. You can kind of see the jack, the middle of the jack here.
Yeah.
But the intention of this thing is you cut out the middle of where the composite part goes, and you'll see that in the later pictures here. But then, I've got these on the side of this board on both sides, you can solder to it.
Oh.
So you would just basically leave these side things standing, right? Because it needs to mount to that. And then you would solder it to that, right? But you need to be sure where it's aligned in the case, right? You can't just willy-nilly solder it to it because it may be too low, it may be too high, right? So you kind of got to, align it to the hole in the case and then solder it down, and then you're good to go, right? And so this one again is a composite. It'll output composite, which is what this jack was for. The whole point of this is so you don't have to make another hole in your case, right? You're using an existing hole that's already there.
Okay.
Right. Now we're just adding functionality to it by not only putting composite out, but left and right audio, line out audio, right, through this jack here. So that's why you have the ABC, which are those are the lines coming from the AY chip, right? G is ground. S is basically sound, or the normal sound that comes from the power supply chip, right?
Okay.
UA78.
Oh, the nice staticky sound?
Right.
Okay.
So,
good.
because since we're taking ABC out of going into that chip, the only thing coming through it is the beeps, right, in the ear,
beeps. Okay.
right, the beep and the ear noise, right, the loading noise, and then 3 and 6 are the pins on the power supply chip that are we're kind of repurposing, right. 3, I think, is maybe ground. So when you plug the jack in, you disconnect ground, so you basically disconnect the power supply chip. So you'll shut off the internal sound to the 2068 when you plug the jack in, right? Which everybody wants. I don't want the sound in the 2068 and to come out. So, okay, well, if you don't want any sound, just plug a dummy jack in there, right? And you'll shut off the sound to the speaker inside. But that's what that is. And there's some other lines here that are extra. These are going actually to that board, David, that was the YUV board that you sent me, and I built up and I hooked it up to this, and didn't really put too great video out.
Okay.
What's the YUV board?
It was a circuit I found somewhere on the internet that theoretically would convert YUV to, was it RGB maybe? I can't remember.
I think so, yeah. Right.
But so YUV are the color values that the 2068 uses internally and then are mixed through this Motorola video chip inside the 2068 to create the composite video signal. And it's, I don't remember, composite and then red minus something and then blue minus something. It's a weird setup.
It's all math, man.
Yeah,
but I'm sure that board could probably, we'd have to tweak it and maybe get it to work better.
Yeah.
But hey, look at that keyboard connector. That's another that's just a bigger version of what was on the 1000.
Yep.
So they still got to make those, I'm sure.
I hope so, because I have just a limited supply of those.
I'm sure they do. I mean, I know in the UK you can buy those because they sell those, all those retro restore places, they have them. But I don't know if they don't have them for the 2068, obviously, but they do have them for the 1000, and I think for the Spectrum too, because the Spectrum uses the same ones.
Yeah.
Okay, so this kind of shows the dongle that I bought from Amazon. So this is the right dongle. You got to make sure that where these go into these pins line up to the proper, that's the whole electrical part of it, right? So you can see yellow is your composite, and of course, right and left audio.
Oh,
So like I
okay.
said, when you plug this in, it's going to shut the sound off internally on the 2068. When you unplug it, you'll get the sound back, right? So, and I know Ryan was all happy about that. So I don't know about Adam. I don't know that Adam really cares, but because I know his machine doesn't really hiss much, but
Oh,
I've heard other
please.
machines that
If
hiss.
that's what you've told me, and I'm like, are you kidding me? There's,
Well,
I
you're
think it,
using a different 2068 now, but this one,
yes.
I listened to it and it's like, it's pretty damn quiet. I've heard some that are really loud.
Yeah.
They have a
I use
lot
it
of
for white
hiss.
noise at night
Oh
so I can
boy.
sleep.
Okay. Okay. But anyway, you see the purpose of this board is to replace the composite jack that's already there, and you'll see in the next. Uh, so this one is where I actually have cut off the composite part, right? And I just
Oh.
left the two wings, right? And so I have put some solder on here, and I haven't got around to it yet, obviously, but it's ready, right? So what I need to do is probably put these wings back into the PC board, back into the motherboard on the 2068, and then probably, plug this, get this board in there and then plug this dongle in so that I can line it up. Because I think this part of the recess here actually fits that hole perfectly in the 2068, right? So it'll center it perfectly in there. And then
Hmm.
you'd solder that board down and then you've got a perfect match, right?
Hmm.
So and this actually has a couple little jumpers on here because, and you can see here, you got either ABC, how the audio output is, or they got the ACB because some software was written for one or the other. I think
Hmm.
most of it's ACB, but there are a few ABCs, or maybe it is ABC because I think that's the way I've got the jumpers. But anyway, you can change it if you totally need to, but I don't think anybody's gonna I don't know anybody. I mean, I know that they have these for the Spectrum, right? And so people have put them in the Spectrum, but so I kind of just adopted it for the 2068. And you're like the Spectrum doesn't have a sound chip. Well, the later ones did, right? The plus threes, the plus two, they had the same AY8912 chip in them too. So anyway, so that's another little project. I don't really call this anything, but it's just the video output stereo mod board or something. I don't know.
Yeah.
And I just kind of took a picture of this because I'm going to show, I haven't got these boards, but I just designed them and sent them out to be built. But you can I just wanted to give you an idea where the sound chip is on the 2068's motherboard in case, a lot of people don't have that memorized, obviously. I kind of do because I look at these things too often. But so, you obviously got the speaker there, but there's, I'm looking, how much room do I have around this to put a PC board? Because I need to get this chip off the board because I don't want to, the ABC audio channels, right, are all
Hardwired.
monoed together, right, on the PCB. So you either pull the pins out, right, or you put this in a socket and kind of bend the pins out, or kind of like let's do this a little bit better. And then the same thing with the power supply chip. And this goes back to David did a video on this actually of using a switching power supply that actually has both 12 volts and 5 volts on one little PCB, right? So you would replace the 12 volt regulator up here and basically replace this chip too. But I still use the op amp that's in here for the internal sound
Hmm.
because there's an op amp built into this thing. So it was supposed to be used for the power supply, but Timex was like, "Whoa, I've got an op amp that we're not using. Might as well just use it for the audio," and that's what they did. So, okay, so here's the board that I'll probably get here next week. So it's designed to break them apart in two pieces, right? I kind of did this because JLC PCB they don't like you to make boards like that because they want you to pay for separate boards, right? So I could make two separate boards, but then I'd be paying $6 instead of paying $2. So it's not really a huge deal, but I was like, that's just stupid. Why can't I just make one board, dudes? And then I'll just break it in half. So I kind of made this power and ground go over to this other side. So they're like, the engineers would be like, oh, they're using the other side. So, okay. So I'm kind of faking them out. But anyway, this is designed to be cut in half, right? So you're going to have this top portion, which is going to be its own board, and this will go over the power supply chip, right? So this brings me all the power supply stuff and the op amp stuff up to this board,
Mm.
right? And then I've got, the other set of connectors is the header pins that would go down and solder into the 26H motherboard, right? So basically I'm go ahead.
Can you go back to the previous image where you showed the power? Okay. I was just curious to see where the
Yeah.
room was for that.
So this one actually has a socket because this power chip was bad on this 2680.
Yeah.
So I replaced it I put a socket in. But anyway, so I know on
Yeah.
yours you took a lot of parts out.
Yeah.
The intention of this board is you don't have to do that. You just really, the best thing to do is to take this inductor out because that's where the +5 comes out. So if you take this inductor out, you totally isolate everything before it.
Mm.
So that's probably what I'm going to recommend you do. But again, you got to, there's only so much space here for a PCB to go in there.
Yep. That's exactly what I was
And
wondering.
right, and that's kind of why this is designed that way. So there's a
So
lot of
are you
room over
building
here.
this for David? Is that what the deal is here?
No, this is going to
Oh.
go into yours because this
Oh.
the sound chip is part of this.
Okay.
So it's because you notice here beep 6 and 3,
Yeah.
those go to that little bitty board that we just talked about.
Okay.
Yeah.
Okay, because
Goodness.
I need to get the op amp circuitry separate from the and then I want to totally disable the rest of the power supply chip because that's where the hiss comes from.
Right.
Or at
I
least
know.
that's what I think.
Yeah.
Right.
Because
What would be good about this is because I'm going to set up an older computer I have with some old composite in stuff to get like a more true experience and capture some of my Astrocade stuff and some of my Timex stuff. And because once the Pico is working like 100% and because it seems to be wrapping up, am I warm
Correct.
there?
Yeah, you're right.
Okay. Yeah, I want to start loading software because it takes a long time to load it, and I can load it now, but I want to use it more, and I'm just sort of waiting, I guess. Yeah,
Mhm.
but so it'd be nice to be able to have, um, I, I guess it wouldn't matter if it was mono, but stereo sound too.
Oh,
Yeah,
yeah,
so as you
yeah.
can see here where the chip is, you've got a lot of real estate over here. Well, not a lot, but I mean, certainly there's nothing really huge here. You don't have to take the switching transistor out, so this board will be standing proud a little bit because, this is a big resistor,
Yeah.
a big diode, fat diode here. This is a kind of a big cap, but I think this board will cover, depends on how high you make it, you can kind of depend on how long the headers you use. I
Yeah.
think I can still get it high enough where it'll clear all that, but still won't, it's not going to touch the top of the case by any means. But
I'm
anyway,
sure we
this
can
gives,
find the right size headers, Carl.
yeah, yeah. So I mean, this is where the power supply module would go. That has the +5 volts out, takes 15 in, gives plus and 12 volts out. Plus, I think it's like an amp or maybe even more. So I mean,
Yeah,
you're
it's
not going
good.
to be running into the lower power. I don't know if when you tried that on your video, David, on your board, did the video get any better? Probably not.
Marginally. Yeah,
Yeah,
a little
yeah.
bit.
So
Yep.
okay. So anyway, this will, the primary thing with this is to get the hiss gone, right, to make it quieter. So I don't know if that'll happen. We'll see with this, but I just decided to make a board instead of, however I was going to hodgepodge it, right?
Mhm.
This makes it a little bit more professional. And like I said, I needed to get the sound stuff to come out too. So that's why this goes over to the soundboard. And then the bottom half, right, this will go over the AY chip. So you'll take the AY chip out of the 2068, you'll put it on here. And again, headers will go down to the board where the AY chip sat. And then now I've got access to the ABC pins individually,
Yep.
right? And then those will go over to the that board, right, along with ground. So you can kind of see this is a fairly narrow board, and going back to, I think it'll fit over here this okay.
Yeah.
Even though this cap's kind of a bigger cap, but I think, I don't think it'll hit the case. But we'll see. But I kind of wanted a PC board for that because if other people are going to do that, I think it's easier for them to desolder this and just solder something in
Yep.
instead of running wires everywhere and cutting traces and shit like that. So
Yeah.
use my English, French. Anyway, so this is coming uh, hopefully next week. I kind of wanted to get it in before. I don't know if the tariffs are going to get higher because, Trump was all pissed off at China again and threatening 100% tariffs on top of what they already have. And so I was like, well, let me get these designed. Another reason, though, is this next project. This is kind of a Ryan put a bug in my ear. And I
Whoa.
did post this on the groups IO. So this is the 2068 interface 0, right? Not only the interface 0 for the micro drives, but it's a twister board, right? So you can put Spectrum stuff on the end, obviously like a twister board would. It has David's video interface, so you can go off to the Sega Genesis HDMI converter. And it has a Spectrum ROM, switcher in it, so you can boot to 2068 in Spectrum mode.
Right.
And unfortunately, Ryan's not here because he was like,
Oh,
I don't know
Ryan's here.
why. Oh, is he?
Yep.
Oh, there he is. Okay. So, because he was like wondering, well, why do we need the interface 0? And if you start looking at what he did is, the 2068 doesn't have a ROM chip select output on the expansion bus, right? So the way the interface 1 works is it uses the ROM chip select to disable the internal ROM so they can use the ROM that's in the interface 1, right, when it switches over. Well, you can't do that in the 2068. There is no ROM chip select line. Right? There's an XROM line, but you can't disable the internal home ROM directly like that on the 2068. You have to use bank enable, right? Of course, bank enable disables everything, but you have to be selective, right, on when you want a bank enable to be turned on. So that's how you would have to do it on the 2068. That's why you can't just plug in interface 1. Even if you had a twister board into the 2068, it would not work because there is no ROM chip select line. So it would not disable the home ROM, right? So Wes Brzezowski or whatever, however you say his name, he came up with the interface 0 thing, which has some interface circuitry, these 3 chips kind of down here in the middle, that number one, they fully decode the IO ports because Sinclair and Timex didn't really decode the IO ports very much because they were just using a bit or two, right? So they never fully decoded them. And the problem with the interface 1 is if you hook it up to the 2068 and you don't fully decode the ports, the 2068 does have, joysticks. It has other, the bank switching circuitry that can freak out the interface 1 because, you're going to be using other bits on these ports, even though that doesn't really control the micro drive, but you're still using some of those ports, right? And so if they're not fully decoded, it can kind of confuse the interface 1. So he made it so that it fully decodes the ports. So you can actually use it in 2068 mode, right? If you just hook the interface 1 up to the 2068, even if you bypass, got through the bank enable thing, it would probably hang it because the IO ports would freak out the ULA that's in the interface 1. So this, port decoder circuitry makes sure that doesn't happen, and it also enables bank enable to disable the home ROM when the interface 1 ROM needs to be paged in, right? And so this is basically a copy of the interface 1 with those additions onto it, including the like I said, David's video output, which is really trivial. That you don't have any circuitry really for that. You just go to the 2068 lines and come out to the mini DIN.
Yep.
But I had to recreate, this is the clock circuitry that runs the ULA in there. And this is the ROM. This is the ULA's ROM. And then there's another decoder circuitry that
Just underneath that.
Yeah. So I kind of go by the naming convention. Well, not naming convention, but see U8, IC1, right? D10, D3, all the normal, under 100 would be like the original parts that were in interface one. Now, when you go to 100, right? Those like U101, U102, U100, these are the decoding circuitries. That's a whole nother added circuitry to the interface one that wasn't originally there, right? So that's how I can kind of tell, oh, that's not part of the original design. That's what I added, right, from Wes. And
Mm-hmm.
then when you get to 200s, like U202, 200, that's power supply stuff. It's all 200 parts, right? And then you get to the 300 parts, and that's the ROM switching, right? To get the Spectrum ROM or the. So I'm using your kind of circuit there that kind of
Mm-hmm.
decodes the bank enable, right?
Mm-hmm.
And hopefully the one that I got was the right one because I know you had a couple of different designs, but
No, that looks like the right one. Yeah.
okay,
With the two
okay,
diodes for the diode logic.
right.
Yeah.
And that's so there's some parts underneath there. Obviously, I kind of using board, although I do have a little bit more board space on this, but still, these probably shouldn't just be out here in the willy nilly. But I just leave them there, whatever. I'll put them someplace else permanently. Um, so this here, like I said, is the whole interface one with the interface zero circuitry, so that you can uh, keep the interface one connected to the 2068 plus you can connect it directly to the 2068 because anybody who knows the interface one, it's kind of designed to fit on the back
Mhm.
of the spectrum and lift it up.
Yep.
So it's kind of at an angle. So that that the spectrum expansion connector that goes into the spectrum itself is kind of at an angle. So it'd be difficult to get it into the 2068 or even on a twister board or something like that because it'd just be pretty unwieldy, right? Because it wasn't really meant for that. So this kind of alleviates all that. It's 2068 bus on one side, Spectrum bus on the other, just plugs right directly into the 2068. Um, what else is on this? So again, so that I made this ROM chip here. Eventually, let's talk about the interface one ROM. This is a direct copy. So again, this is kind of like the Spectrum ROM, not Spectrum. Well, Spectrum ROM too, but the 1000 ROM, right? It's a
8K.
mask ROM or a one-time programmable ROM. So the pins are unique to those kind of chips. So
Mm.
you can't just put an EEPROM or a flash chip in there. So this will have to get redesigned at some point. But and I only have one interface one, so my intention was to use the chips out of it, at least the ULA and the ROM. Everything else is duplicated, so I don't have to take anything else out. But I don't have spares of those. And luckily, again, Charlie has made a FPGA version of the interface one ULA. But of course, with Trump's trade war, they won't ship to the U.S. right now because they had that stupid rule or whatever.
Yeah.
So they can't. You go to his site and it says we don't ship to the USA right now. So I couldn't get one from. I had to get one maybe the UK or maybe somebody has one here. That guy from New York that we were talking to at the show, he's got a bunch of these ULAs. I don't know if he has the interface one, but he does have like the Spectrum one and the ZX81 one.
Cool.
Anyway, so that'll have to get redesigned at some point. The ROM, the Spectrum ROM, though, this is a 512K chip, so it's a 64K chip, right? So it has possibly four 16K ROMs you can put in it.
Yep.
And the reason I kind of put that there is because, and you can select the addresses up here, but normally it would just be a Spectrum ROM, right? You switch the switch on, power the 2068 up, and come up in Spectrum mode, and that's how we intend to test this, right? Because it has to be in Spectrum mode. But you need to get the interface one connected to the 2068 with the interface zero circuit. All that stuff has to be there too for that to even work. So as you notice over here on the left side here, that's where the microdrive goes, right? That directly goes to the microdrives. Although I think I need to flip this where the notch will be further down because it won't be a nice smooth cable transition to the microdrive. If you look at the interface one, this notch is on the bottom side. So not a big deal. It'll work, but the cable will have a little twist in it, right? It just won't look aesthetically as nice as it would have. But anyway, the second, I'm going to probably put another ROM in here. That is, now I'm drawing a blank now. What was my other ROM? Oh, I've got a Spectrum test board. right? That they make a Spectrum test board that has all, like all the LEDs on the address and data lines and power supply LEDs, and it's got its own program, a diagnostic program, right? That's in there. Obviously, I think that's running its own ROM. I think it shuts off the internal ROM in the Spectrum and uses that ROM. Otherwise, how would that work? I don't. Maybe it's running in a different address space and calling ROM things, but I think it uses its own ROM so it can run the machine, even if the ROM is bad, right? So again, that's going to use the ROM chip select just like Interface One would, and that's not going to work on the 2068. But since we have the bank switching circuitry here already, so we can make that work. I'm wondering if I put that diagnostic ROM in another page here, another chunk, and switch to it, select it, and then boot it up in Spectrum mode. It'll boot up that diagnostic ROM instead of the 2068's home ROM, and maybe it'll run the diagnostic software.
Mm. Mm. Very cool,
Right.
Carl. Very cool.
And then you can plug the board into here so you can get all the LEDs and stuff, right?
Yeah.
So anyway, I know I'm kind of
I'm gonna give you
running.
the hook, Carl.
Yeah, just this one last board here.
Like, no, wait, I've got more.
Well, it's just I couldn't fit. Well, I could probably fit, but it would just get a little bit complicated. There's also network circuitry in the interface one, right? You have the two headphone jacks, right, for the Spectrum Net or whatever the hell they called it.
Yeah.
Let's just use the headphone jack, and they had an RS-232 9-pin port. So this board here is all that circuitry, and you notice the net headers here, which will plug straight into these. So it's designed to go again on top of this board.
Oh, I see. Yeah.
Right. So you don't have to have this. It's not going to prevent this from working, but you just won't have any network stuff. And of course, the reset switch won't work because that's on here too. But anyway, so that's all my shit. So yeah, I know. Sorry about it. I'm 2 hours of this. Holy crap! I didn't think it'd take that long. But
you're a talker, Carl.
Well, a lot of projects, man. A lot of projects.
Yeah. Very cool.
Hopefully, hopefully you guys will see the fruits of my labor here at some point. And I don't know who's interested in any of that, but I'm sure some of you are. But anyway, I know I am. So
I did have a question, Carl, about I guess it was the previous one with the sound chip.
Okay.
Is it possible and even useful to have the sound chip alias to the Spectrum 128 port as well?
I mean, we'd have to put some more decoding in there, circuitry to decode it, but I'm sure we could do that.
Yep. Yeah.
Maybe have a switch.
It was just also a question of is that useful for like if you're running some Spectrum games that use a 128 sound chip?
Yeah, I mean, because it's going to go to the different port, so you wouldn't hear any sound on the regular 2068.
Yeah.
Oh, and one other thing too is, you don't have to go back to focus on me, but there's another thing if you read some of Wes's articles, there's some Spectrum programs that wouldn't run on the 2068, even though you were using the Spectrum ROM, right? Because Timex they didn't pull high all the data lines. So when you would go like do an in, you would get random shit because the only one that they pulled high was D2.
Yep.
Data line 2 was the only one that has a pull up. So I guess some of these Spectrum programs, they expect an FF for some reason. And if they don't get that, they crash or they wouldn't work. So that board also has the pull up that pulls all the data lines high. So those Spectrum programs will work on the 2068. Another little tidbit.
Time for a little business. Bye, Tim. Our next meeting is Monday the 3rd at 9 p.m. Eastern. So you do the math for whatever that turns to in your time. I'm not good at that kind of math. And we are entering holiday season. So, November is the month in which we consume turkeys. And then, December is the month in which we, I don't know, throw snowballs or something like that. Um,
Maybe where
so
you live.
exactly where I live, absolutely. Um, we have had in the past some seasonally appropriate programs that we've resurrected from, family computing and other places off of ancient cassette tapes. Ryan had a program or two for the 1000 that, did something Christmassy, if I recall correctly. Uh, so, if you're feeling like programming between now and, any of our next meetings, uh, take up the challenge to make something seasonally appropriate. I mean, it just could be as simple as like a Christmas tree that, with the twinkling lights or something. That would be easy to do on the 2068. It'd be a little harder to do on the 1000, what with the lack of color, but you could still, have a black and white tree. It would be the down rent tree. Um, obviously you can't do sound on the 1000 as easily, but um,
You
uh,
can soon.
you can
Just
soon.
get
Exactly.
my board.
So, so yeah, let's if you're feeling like programming, make something. You put your computer skills to use. I know some of y'all can program in BASIC.
Well, there's a lot of programs out there already, right? I mean, that are archived.
For the Spectrum, probably, but the in terms of 1000 or maybe ZX81 stuff, I haven't really looked in the for the British side of the 81, and they don't have Thanksgiving. Uh,
Right.
right. But yeah, maybe there's something that we could bring over from the Spectrum side that doesn't require. Maybe it's all programmed in BASIC and can just run directly without any changes. That'd be worth looking into and see if there's. I'll do some digging. Um, the other thing that I wanted to mention was I'm gonna turn off my background here because it's just choose but just background. There we go. None. Okay, so this thing here. Oh, come on, focus, would you? All right, I'm not gonna worry about it focusing.
Could
Um,
you make it so well, I guess I can do that myself, but
oh
so I
yeah,
just
yeah, I
see,
know what you're saying. Spotlight for
yeah,
everybody.
yeah.
Spotlight for everyone. Okay, cool. There we go. This is this is a modern version, idea of the Timex Sinclair 2060 bus expansion unit, right? So bus connector here plugs into the back of the 2068, expansion connector here, so you can plug things further into it. A single um, set of pin headers right here that you can uh, eventually put a riser on and have a card go horizontally. So if there's something that this doesn't do that you want to do, that's what it'll do. FPGA that Jeff Burrell is programming to do all the magic, some RAM. Oh, sorry, I'm working backwards here. Um, why does this software do this? Anyway, uh, this is a big Pico. This is the next version of the Pico that has a lot of pins on it um, that will run a bunch of the software. This is a stereo DAC, so stereo audio out. Sorry, USB connector where you could plug in a mouse or a keyboard, which is also connected to this. Come on, there we go. Connected to this USB device. This is actually a very small Pico. Power supply modules, Wi-Fi module, and SD card module. What have I left out? These two connectors. One is a VGA connector, and if I recall correctly, the other one is joystick or serial. I can't remember which one. Oh, and a space for a real-time clock. So, tons and tons of features, and the way that Jeff is designing the hardware, it will. when it'll load, all sort of the support hardware to work with uh, uh, a 2068. So extends the 2068 like the TS Pico extends it, so you can load and save to the SD card and do all these other features. But it will also load within the FPGA. It'll load a Spectrum core. I think he's working on a ZX81 core and some other cores, so that you want to run a Spectrum program. Boom, you load the Spectrum core. It talks to the SD card. You can load stuff from the SD card, um,
Hmm.
etc. So very ambitious. The goal is to have, we actually want to have an enclosure for it. So Joe Van de Zande is working on designing that. There'll be a 3D printed enclosure, um, and it will have enough um, inside support to support an LCD monitor,
I
not
want
a
a CRT
CRT,
monitor on mine, so
not a
forget it. I don't
CRT.
want it. I don't want it anymore.
Um, and they've been working on this for months, less than a year. Yeah, so Tom asking about final cost. Don't know yet. Um, the two biggest expenses are the PCB, which is large, and that is, not cheap. I don't know as sort of Carl alluded to earlier, when you order PCBs through most companies, it's dependent upon size. Um, and the bigger it is, the more expensive it is. The other thing is that there's a lot of surface mount parts, and I would prefer to have the PCB manufacturer mount as much of the surface mount stuff as possible, so that when it comes to actually finishing it up, there's only a few things to solder. And then the other really big expense is going to be the enclosure, and we don't have pricing on either of those things yet. And the tariffs are certainly not going to help the situation right now.
So I know we're going to talk about this more next time, but it's as wide as a 2068.
Yes, it is. Yeah,
Is
actually.
that what it is?
So if you have looked on my website, timexsinclair.com, if you look for the bus expansion unit on the website, there'll be a picture of this entire system that Timex came out with. And the 2068 was meant to plug into the bus expansion unit, and so they would sort of become one unit. And you can see in the picture that clearly the 2068 goes into a certain amount into that bus expansion unit, and that's the goal here as well. Is
Oh,
it's
so
gonna
you're mimicking it as closely as possible.
well closely, yeah. But I mean, for
Yeah,
instance,
the way it looked anyway,
one of the things
and
that
size
we're
wise.
going to do a little different is um, we're going to have a little slot on the front bezel for where you plug in your SD card, and then we're also going to have a little space for one of these really small OLED displays that are like 128 by 96 pixels, which is just enough to display stuff like, here's the file that you've mounted, or a tiny bit of your directory, or whatever. A little bit of feedback. And then there'll be a couple, there's a reset switch pin header on the board, and we haven't yet figured out where to put the reset switch, on the device yet. But
By the space bar.
um, maybe where the delete key is. Yeah, yeah. So it's progressing rather well. Jeff just sent out an update of software to it that he wants us to test out, and I mean, just the demos that he's shown us so far have been really really nifty. Oh, and he has programmed into the FPGA native support for 64 and 80 column modes, which don't use, because it has its own RAM. They don't use the RAM in the 2068. And so Gustavo doesn't know this yet, but he'll know it in a second. I'm hoping Gustavo will figure out a way to extend the 2068's ROM to enable that and talk to it natively, so that we could like turn on a 64 column mode and have in the 2068 now you turn on 64 column modes and you're using twice as much video RAM because of the way it works. But I'm hoping Gustavo will figure
Yeah,
out a
hi,
way to
I'm
natively
here.
enable those things. Yes, sir.
Okay, hello, all the group. No, the idea is to support the advanced operating system like CPM or whatever.
Oh, that too. Yes.
Yeah, in this
Why
mode we
not?
have no. In this mode we have an extension of the TPI commands and exchange all the board, the low level architecture of the FPGA at the Pico with the extension of the CPM. And that will be possible to add many new features, including the new Wi-Fi Pico on board, because we think to extend to connectivity of this
Right.
2060. And yes, the idea is to do compatible with the all existing software. That is one of the development point, and that's why we use the TPI extension of the basic. We can use save load, the standard commands as the Timex use and tape. We assure that all the existing program could be run without modification. We don't need a special extension like the interface one or one other storage devices. You can use save and load just at standard tape format. This is the main concept of that.
So on that note, thank you,
Yeah, I
gentlemen.
end.
Cool.
And we'll see you November 3rd, 9 p.m.
At 7 p.m. Eastern time.
7, whatever, yeah, whatever time. Just show up and maybe
Show
people
up.
will be there.
Okay.
Yeah. Cool. Cool. Oh, and John is plugging the Chicago TI 99 4A user group.
Yes, we're having a festival at the Evanston Library next Saturday.
Oh, nice.
So if you can make it to Evanston Library next Saturday, you can be part of the fun. There might be like 50 people there.
Wow.
It's a 1 day only, and it's fun.
Cool. Cool. All right. Thank y'all. See
All
you
right. See y'all
in
later.
2 weeks-ish. Right.
Okay. Bye.
Good one, guys.
See
Sorry
you.
for taking so much
Bye.
time.
Thank you, Carl.